As philosophers, we're always trying to untangle these intricate webs of reasoning and logic, dissecting arguments, evaluating truth claims, and exploring the very nature of reality.
Absolutely.
But at the core of it all, there's this really fundamental activity: making decisions.
Right.
And what if I told you that the key to truly grasping rational choice, that's something deeply philosophical?
Oh, I'm intrigued. Tell me more.
Well, it lies in understanding the intricate relationship between cause and effect.
Okay, yeah, that makes sense. I mean, we all kind of have this intuitive understanding that our actions have consequences, right?
Right.
But the moment we try to, like, formalize it, how we should make those decisions, especially when you throw in uncertainty and all of that,
Yeah.
it gets really complex really quickly.
It does. It absolutely does. And that's precisely where causal decision theory comes in.
I see where you're going with this.
It really does, yeah. So for this deep dive, we've really immersed ourselves in, well, you could call it a cornerstone of philosophical scholarship, the Stanford Encyclopedia of Philosophy.
Oh, yeah, the SEP.
The SEPI, it offers this incredibly rigorous and detailed exploration of causal decision theory.
That's great. So it's almost like we're having this focused conversation, tailored specifically for, like, our listeners' philosophical toolkit.
Exact.
We're unpacking these core ideas and debates surrounding how we actually make choices when causes and effects are, they're really at the forefront.
Absolutely. So to really kick things off, let's just give everyone a high-level view of what causal decision theory is all about.
Sounds good.
At its heart, it argues that when we're faced with a choice, we really need to focus on how are our actions going to causally influence the outcomes that we really care about,
Right.
rather than simply looking at what actions might just be correlated with those outcomes.
So it's about being effective, you're saying?
It's about being effective. It's about making those choices that actually work to bring about what we want, not just doing things that happen to be good indicators that those things are going to happen anyway.
I get it. It's not just about auspiciousness. It's about efficacy.
Exactly. It's about efficacy.
Like, you don't want to just do something that happens to be a good sign that something good will happen.
Yeah.
You want to actually make that good thing happen through your action.
Right.
Okay, that's a really important distinction. And I think to really grasp why that difference is so crucial, we kind of have to delve into the whole concept of expected utility.
Okay, let's do it.
All right. So the standard framework for thinking about rational decisions often centers around this idea of maximizing expected utility.
Right.
What we do is we identify the possible outcomes of each action. So, like, what could happen if I do this? What could happen if I do that?
Okay.
And then we assign a value or utility to each outcome. So how much do we actually want each of those things to happen?
Okay.
Right? And then we sort of weigh these utilities by the probability of each outcome actually occurring.
Got it.
Right? So if I take this action, how likely is it that this will happen? How likely is it that that will happen?
Okay, so we're taking into account the likelihood of each outcome and how good or bad it would be.
Precisely. And the action that gives us the highest average utility, considering all those probabilities, is typically thought of as the most rational choice.
That sounds pretty straightforward, like on the surface level.
Right.
But then things start to get really philosophically interesting, don't they?
They do. They totally do. It's like, okay, this seems simple, but there's always a catch in philosophy.
Yeah.
So what's the catch?
Exactly. So let's consider this. Think about a student who's, deciding whether or not to study for an exam.
Classic philosophical example, the student and the exam. Okay, I'm listening.
Right. They might think to themselves, look, if I'm going to pass anyway, then all this effort of studying, it's just a waste of energy.
Makes sense.
And, if I'm going to fail no matter what I do, then studying, it's pointless.
Yeah.
So either way, studying, waste of time.
Oh, I see the problem. This is the classic correlation versus causation issue, isn't it?
It is. You got it. This line of reasoning, it seems logical, but it misses a really crucial causal connection. The act of studying can actually increase the probability of passing that exam.
Right. Because you're not just a passive observer. You can actually influence the outcome through your actions.
Exactly. Exactly. By just focusing on that correlation, the potential outcomes pass or fail, and the action of studying, the student misses the fact that studying can actually be a cause of that better outcome.
It's like they're treating themselves as if they have no agency in this situation, no power to change things.
They are, and it's just not how it works, right?
No, not at all. So how do we actually account for this causal influence then? Because it seems like just looking at correlations isn't enough.
It's not. And our source mentions the use of conditional probability, that is the probability of an outcome given that a particular action is taken, as one way to try to, accurately calculate that expected utility.
Okay, so in our student example, we could look at the probability of passing if they study, multiplied by the value of passing, plus the probability of not passing if they study, multiplied by the value of failing.
Yeah, exactly.
We're getting closer, right?
Yeah.
At least we're acknowledging that our choices actually do something. But even with conditional probability, there are still some limitations when it comes to really, truly capturing causal influence, right?
There are. There absolutely are.
Give me an example.
So imagine you're flipping a coin, right? And you think it might be a little bit biased.
Okay, I've got my coin. It's a bit dodgy.
And that first flip, it comes up heads.
All right, heads it is.
Now, that's evidence that maybe it is biased towards heads.
Yeah,
So the probability of getting heads on the second flip, given that the first one was heads, might be higher.
makes sense.
But the first coin flip didn't cause the second one to be heads.
Right. It's correlated because of the underlying bias of the coin, but there's no actual causal link between the two flips themselves.
There isn't. And this is where causal decision theory really steps in and makes its claim.
Okay, lay it on me.
It asserts that when we are making those decisions, we shouldn't just be looking at what our actions tell us about the state of the world. We need to focus on the actual tangible causal influence that our actions have on bringing about what we want to happen.
So the aim is to actually bring about the outcomes that we want through what we do, not just do things that happen to correlate with those outcomes, even if the correlation is really strong.
Exactly. It's about being effective.
Yeah.
It's about having that causal influence, not just happening to be a good predictor.
Right, because sometimes doing something that's a good sign that something else will happen isn't the same as actually making that thing happen.
Exactly.
And there's a classic philosophical thought experiment, the prisoner's dilemma, that really highlights this, especially when you add this interesting twist of psychological twins to it.
Oh, that's a good one. A lot of philosophers have really wrestled with that.
Oh, they have. It's a great example. So just to remind everyone, you've got these two individuals. They're completely isolated from each other.
They can't communicate at all.
No communication whatsoever.
Yeah.
And they have to decide independently whether to cooperate with each other or to defect, to betray the other.
Classic dilemma.
Classic. So if they both cooperate, they both get a moderate benefit.
Everyone's happy.
Yeah, everyone wins a little, but if they both defect, they both suffer a moderate loss.
Okay.
So not ideal, but here's the kicker. If one defects while the other cooperates, the defector gets a huge benefit, and the cooperator, well, they suffer significant loss.
Right. So there's a big incentive to betray.
Huge incentive. Now let's throw in these psychological twins. Imagine these are individuals who think exactly alike, same beliefs, same desires. They know this about each other.
They're basically clones in terms of how they think.
Exactly. So in this scenario, if one twin decides to cooperate, they know with near certainty that their twin, because they think exactly the same way, will also cooperate.
Right. So their act of cooperating becomes evidence that the other twin will also cooperate.
Strong evidence. And if you're just looking at conditional probability, it seems like cooperating has a higher expected utility because, hey, your cooperation is a great sign that they'll cooperate too.
You're basically predicting the future based on your own actions.
Kind of, yeah. But here's the thing that causal decision theory really wants us to see. Your twin's action isn't actually caused by your cooperation.
They're still isolated.
They are. There's no way for your choice to directly influence theirs.
It's just that their choice is a reflection of your own thought process because you're so similar.
Precisely. And since each twin, individually, is always better off defecting no matter what the other one does that's like, the dominant strategy and the prisoner's dilemma causal decision theory, which cares about the real causal impact of your action, would say, defect.
Defect, because cooperating might be a good sign, but it doesn't make the other twin cooperate.
Exactly. And this brings us to one of the most famous and honestly one of the most brain-twisting puzzles in all of decision theory, the one that really shaped the development of causal decision theory, Newcomb's problem.
Oh yeah, Newcomb's problem, the philosophical puzzle that just won't quit.
It's a classic. So are you ready to dive into this one?
I am. Let's do it.
All right. Buckle up, listeners. Newcomb's problem presents this scenario where our intuition about what's rational just pulls us in two completely opposite directions.
Yeah, it's like a philosophical tug of war.
Totally. So here's the setup. You're presented with two boxes. One is opaque, you can't see inside. The other is transparent, and you can see it has $1,000 in it.
Easy choice so far.
Right, not so fast. You have a choice. Take only the opaque box or take both.
Okay, now it's getting interesting.
Here's the catch. The contents of that opaque box, either $1 million or absolutely nothing, were decided by a super reliable predictor before you even made your choice.
So someone's already tried to guess what I'm going to do.
Exactly. They predicted your choice. If they thought you'd take both boxes, they left the opaque box empty.
Sneaky.
But if they predicted you'd go for only the opaque box, they put $1,000,000 in it. And you know this predictor is almost always right.
Wow. Okay, so there's a lot to unpack here. Let's think about the arguments for each choice. From a pure dominance perspective, taking both boxes seems like the obvious winner, right?
Yeah, because no matter what's in the opaque box, you're guaranteed an extra $1,000 by taking both.
You're always coming out ahead, at least a little bit.
So two boxing dominates one boxing. Straightforward, right?
Seemingly, yeah. But now let's think about it from the perspective of expected utility, especially using those conditional probabilities we talked about.
Right, where we factor in the evidence our choice gives us.
Exactly. Since the predictor is so reliable, your choice now is really strong evidence about what they predicted and what they put in the box.
So if you choose only the opaque box, that's like screaming evidence that they saw it coming and put the $1,000,000 in there.
Right. And if you take both, well, that probably means they predicted that and left the opaque box empty.
So your choice is like a self-fulfilling prophecy in a way.
It is. It's like you're influencing the past with your present choice.
Hmm.
So when you look at the expected utility based on those conditional probabilities, what you're likely to get given your choice one boxing seems way better.
You're more likely to get that million if you only take the opaque box.
Exactly. And that's the paradox. Dominance says take both boxes, but expected utility, using those conditional probabilities, says take only one.
It's a real head-scratcher.
It is.
Huh.
And this isn't just some orky thought experiment either. Our source points out that there are real-world situations called realistic medical Newcomb problems where this comes up.
Oh, interesting. So, like, maybe there's a certain lifestyle choice that's correlated with not getting a disease, but it doesn't actually cause you to not get the disease.
Exactly. Dominance might say, do the healthy thing, but expected utility, based on those correlations, might say, well, it doesn't really matter.
It's like our intuitions are battling it out.
They are. And it's similar to the prisoner's dilemma with twins, right? Doing something that seems to lead to a better outcome based on correlation, but it doesn't actually cause that outcome.
It's all about that causal connection. Okay, so how does causal decision theory try to resolve this head-spinning conflict between dominance and expected utility in Newcomb's problem?
It's a big question, and our source introduces Robert Stalnaker's solution. He uses the probabilities of subjunctive conditionals instead of those standard conditional probabilities.
Subjunctive conditionals, those are like what-if statements, right? Exploring what would have happened if something different had been done.
They are. And unlike regular conditional probabilities, which are all about, given this is true, what's the probability of that? Subjunctive probabilities look at scenarios that might not actually happen.
So it's like looking at alternative timelines, almost.
Exactly. So Stalnaker said, when we're figuring out expected utility, especially in tricky cases like Newcomb's problem, we should be thinking about the probability of statements like, if I were to take only one box, then the predictor would have predicted I would take only one box.
Okay, I think I'm following. So instead of just looking at what happened, we're considering what would have happened under different circumstances.
Exactly. And here's the crucial difference, according to causal decision theory. In Newcomb's problem, your action right now, whether you take one or both boxes, it doesn't causally influence the prediction that was already made.
Because that prediction happened in the past, and your action is in the present. You can't change the past.
Exactly. So the probability of that subjunctive conditional, if I were to take one box, then the prediction would have been one box. Well, it's just the probability that the prediction was one box.
Your present decision can't reach back in time and change what the predictor already did.
Exactly. And that leads to a really interesting result. When you calculate the expected utility of both one boxing and two boxing, using these probabilities of subjunctive conditionals, it becomes clear that two boxing is always better.
Because you always get that extra $1,000 no matter what the predictor did, and you're not actually changing the outcome in the opaque box.
You got it. You're just maximizing your gain in the present moment.
So causal decision theory, by using these subjunctive conditionals, is saying focus on what you can actually control, not on trying to outsmart a predictor who's already made their move.
Exactly. It's about making the best decision given the current state of the world, not trying to rewrite history. And this difference between evidential and causal reasoning, well, it was really fleshed out by Gibbard and Harper.
Right, they made a clear distinction between evidential decision theory and causal decision theory.
They did. Evidential decision theory, that's all about using those conditional probabilities and focusing on the evidence an action gives us about a good outcome.
Like, is this action a good sign that things will go my way?
Exactly. But causal decision theory, that focuses on the actual causal power of an action to bring about those outcomes.
It's about what you can actually make happen.
It is, and they argued that causal decision theory is a much more accurate way to think about rational decision making, especially when correlations and causation don't line up.
Which, as we've seen, happens more often than we might think. Now, Stalnaker's approach using subjunctive conditionals, it was really important for causal decision theory.
Hugely influential.
But it's not the only way theorists have tried to make those core ideas precise, right?
It's not. Our source talks about other ways to calculate those causally sensitive expected utilities without using subjunctive probabilities directly.
So, other ways to bake causality into the decision-making process.
Exactly. People like Brian Skyrms and David Lewis, they came up with alternative frameworks. Skyrms, he talks about figuring out which factors you could actually influence and which ones are just out of your control.
Right, so you're not wasting effort on things you can't change.
Yeah. Exactly. And then you calculate your expected utility based on what he calls the K expectation.
So you're sort of narrowing down the possibilities to the ones that are relevant to your actions.
Yeah, you're focusing on the things you can actually impact. And Lewis, he talks about dependency hypotheses.
Dependency hypotheses, what are those?
Basically, they're like really specific propositions about how the things we care about depend on our actions.
So it's like a detailed map of how my choices lead to different outcomes.
Exactly. So instead of directly dealing with those what-if scenarios, these approaches build that causal structure of the world right into the framework for evaluating actions.
It's like saying, given that the world works this way, with these cause and effect relationships, what's going to happen if I do this particular thing?
Exactly. And the remarkable thing is that these different versions of causal decision theory, even with their different tools and concepts, they often agree on what we should do.
So they're all pointing in the same direction, even if they're taking different paths.
They are, especially when it comes to those tricky cases like Newcomb's problem.
That makes me feel a bit more confident about the theory, knowing that there's this convergence of different approaches.
Me too. It's a good sign. And our source also mentions something called representation theorems, which are pretty important in decision theory.
Representation theorem.
They try to connect those ideas of probability and utility to an agent's actual preferences. It's like they're trying to ground these abstract concepts in something more concrete.
So are they saying that probability and utility are just about how coherent our preferences are?
Well, that's one interpretation. Another view is that these theorems are more about showing that we can actually measure probability and utility in a way that makes sense for maximizing expected utility.
It's like we're trying to figure out if these are just convenient tools for thinking about decisions, or if they reflect something deeper about how our minds actually work.
Exactly. It's a really interesting area of ongoing research. But okay, let's shift gears a bit. We've talked about what causal decision theory is, how it works, and some of its strengths.
Right.
But as with any philosophical theory that's gotten a lot of attention, it's also had its fair share of criticism, right?
Yeah, no theory is perfect, and people are always going to find things to disagree with.
Exactly. So what are some of the main philosophical objections that people have raised against causal decision theory?
Well, the one that keeps coming up, and it's a pretty intuitive one, has to do with its recommendation for Newcomb's problem, that we should take both boxes.
Yeah, a lot of people find that really counterintuitive, even after you explain the whole dominance argument.
I get it. It just feels like taking only one box should lead to a better outcome.
Right, because those who do tend to end up with $1 million. But the typical causal decision theory response to that intuition is, yes, it's likely that one boxers will get more money, but that doesn't make the choice to one box rationale in the moment of decision.
So it's like saying that just because something tends to happen a certain way doesn't mean that's the best way to approach the situation.
Exactly. They argued that Newcomb's problem is kind of a weird case, set up to reward a seemingly irrational strategy.
It's almost like a trick question designed to expose the limitations of our usual ways of thinking about rationality.
Right. And the dominance argument, the one that says you should always take both boxes to maximize your guaranteed gain, well, that still holds from a causal perspective.
Because you're not actually changing the contents of the opaque box by taking both.
You're not. You're just making the most of what's already there.
And some theorists even try to reconcile the two intuitions by saying that while two-boxing might be the most rational choice within the specific context of Newcomb's problem, it might be a good idea to cultivate a disposition to one box as a way of preparing for such scenarios.
It's like saying, if you know you're going to encounter these weird situations where the predictor is almost always right, maybe you should train yourself to act in a way that takes advantage of that.
Right, so it's not about making the wrong choice in the moment. It's about developing a strategy that works well in the long run. Exactly. So there's that response.
Okay, what other objections are there?
Well, there's also a more traditional philosophical objection, sometimes called the positivist objection.
Positivism, that's the idea that we should stick to things that can be observed and measured, right?
Yeah, and some philosophers who lean towards positivism, they're not too comfortable with making causation so central to a theory of decision.
I can see why. Causation can be a slippery concept. It's not always easy to observe directly.
It's not. And they argue that a good theory of decision-making should stick to ideas that are more firmly rooted in empirical evidence.
So things we can see and measure.
Exactly. But causal decision theory has some responses to that.
What do they say?
Well, first, they kind of challenge the strictness of positivism, arguing that even things we can't directly observe can still be really important for understanding the world.
So not everything has to be directly observable to be real or meaningful. Exactly. And second, they've offered a lot of clarifications and ways to formalize causation, trying to make it a more well-defined concept.
So they're trying to make causation more rigorous and less mysterious.
Exactly. They're saying, look, we can pin this down, even if it's not as straightforward as some other concepts.
Okay, that's a reasonable response. Are there any other major objections?
There's one more that's worth mentioning, and it has to do with what philosophers call conceptual economy.
Conceptual economy.
Yeah. Basically, it's the idea that a simpler theory is often better than a more complex one if they both do the same job.
So it's like Occam's razor, right?
Yeah.
The idea that we should prefer explanations that don't multiply unnecessary entities.
Exactly. And some philosophers argue that maybe evidential decision theory, the one that just focuses on correlations, could actually make the same recommendations as causal decision theory, but without all the extra baggage of causation.
So it's like saying, why bring in causation if we can get the same results just by looking at correlations?
Right. And Ellery Eels, he's a philosopher who's made this argument pretty forcefully. He came up with something called the tickle defense.
The tickle defense. That's an interesting name.
It is. So his idea is that in Newcomb's problem, if you really think about it, your choice is just evidence of what the predictor did.
Because the predictor is basing their prediction on your psychology, right?
Exactly. So there's this common underlying cause, your own psychology. And once you account for that, the correlation between your choice and what's in the box is screened off.
Screened off. What does that mean?
Basically, it means that the correlation doesn't actually tell you anything about the causal relationship. It's like seeing a correlation between ice cream sales and crime rates, but it's the heat that's actually causing both.
Okay, so the tickle defense is saying that once you understand the common cause, the correlation becomes irrelevant for decision-making.
Exactly. And Eels argues that this would lead evidential decision theory to recommend two-boxing as well, just like causal decision theory does.
So he's saying that we don't need causation to get to the right answer.
That's his argument. But there are some pretty strong counter-arguments to the tickle defense.
Like what?
Well, for one thing, not all agents make decisions based on a perfectly clear understanding of their own beliefs and desires. And even if they do, they might not know exactly how those internal states lead to their choices.
So it's like saying, even if I know what I want, I might not be fully aware of all the unconscious factors that influence my decisions.
Right. And in those cases, the choice could still be evidence about what the predictor did, even if it's not causally influencing it.
Okay, so the screening off argument only works if we have a really high level of self-awareness and understanding of our own decision-making processes, which might not always be realistic.
Exactly. And that's why the claim that evidential decision theory can always do the same job as causal decision theory, well, it's still up for debate.
It seems like there are cases where causation really matters, even if correlation can be a useful shortcut sometimes.
Okay, so we've talked about some of the objections to causal decision theory.
We have.
What about some of the current issues and active areas of research in the field What are people still working on?
There's a lot going on. Our source mentioned some really interesting areas. One is about how we interpret those fundamental concepts of probability and utility within the theory.
Right, because probability can be tricky. It can be subjective or objective, and utility can be about your personal desires or something more universal.
Exactly. So are those probabilities in causal decision theory just about what the agent believes, or are they based on some objective understanding of how the world works?
And is utility just a matter of taste, or is there something more objective about what's good and bad?
Really deep questions. And since causal decision theory is all about those actual causal pathways, it tends to lean towards a view where our subjective beliefs and desires should line up with the objective reality of the world. So we should try to make our beliefs and values reflect how things actually work.
Exactly. And then there's the ongoing search for the best way to formally represent those causal probabilities, whether it's through those subjunctive conditionals, using probability images, or other mathematical tools.
So people are still trying to refine the language and the math of causal
They
probabilities.
are. And another big area of discussion is about partition invariance.
Partition invariance, remind me what that is again.
It's the idea that how we divide up the possible states of the world shouldn't affect how we evaluate an action's expected utility.
Right, because our decision-making framework shouldn't change just because we decided to categorize the possibilities differently.
Exactly. And David Lewis, he pointed out that a pretty simple formula for expected utility actually doesn't always follow this rule.
So there's a potential problem with the math.
There is. And since then, people like Sobel and Joyce, they've come up with more complex formulas to try and fix that, often focusing on the utility of an act given a specific state rather than just the combined utility of the act and the state.
Okay, so they're trying to make the math more robust and less sensitive to arbitrary choices about how we categorize things. And what about the nature of outcomes? Are we talking about entire possible worlds or just the specific consequences of an action?
Another good question. And how do our basic desires and aversions fit into all of this?
Right, because ultimately we make decisions based on what we want and what we're trying to avoid.
Absolutely. Our source points out that we can even calculate expected utility directly from those basic desires and aversions.
So like, if I do this, how likely is it that I'll get what I want and avoid what I don't want?
Exactly. And then there's the really tricky question of how we think about the acts themselves when we're deliberating.
Right, because if we're trying to decide what to do, can we even assign probabilities to our own future actions?
It's a tough one. Isaac Levi, he argued that we can't. He said that the very act of deliberating makes it impossible to predict our own choices.
Because if we already knew what we were going to do, why would we even deliberate?
Right. It's like deliberation itself changes the probabilities.
Makes sense. But our source mentions that James Joyce has some counterarguments to Levi's position.
He does. He says that while causal decision theory doesn't force us to assign probabilities to our own actions, we can still do it without messing up the decision-making process.
So it's allowed, but not required.
Exactly. And he also introduces this idea of evidential autonomy, which basically means that when we're making a free choice, we don't have to base our beliefs about what we'll do solely on past evidence or predictions.
So we have some freedom in the moment, even if our past behavior and other people's predictions can give us some clues.
Exactly. And then there's the deterministic universe objection.
The determinism, that's the idea that everything is predetermined, right? No free will.
Right. And Arif Ahmed, he's a philosopher who's argued that if the universe is deterministic, then the whole idea of causal influence, the way causal decision theory uses it, well, it might not make sense.
Because if our choices are already set in stone, how can we really say that they cause anything?
Exactly. It's a really deep philosophical challenge. And some theorists have tried to tweak causal decision theory to address this, but it's still an ongoing debate.
It's a big one for sure.
Yeah.
So what about some of the more practical challenges? Like what about situations with infinite utility, like Pascal's wager or the St. Petersburg paradox?
Those are always fun, and they really push the limits of the standard expected utility framework.
Because how do you calculate the expected value of something that could be infinitely good or infinitely bad?
Right, and causal decision theory has to grapple with these challenges too, just like any other decision theory.
It seems like there are always going to be these extreme cases that force us to rethink our basic assumptions.
There are.